Welcome back to the Intermediate Talks track. If you had a chance to look at our State of Spring Survey 2021 results that we released yesterday, you'll know that Spring Data, Spring Security, and Spring Web MVC are modules that more than 3 out of 4 Spring projects have. Out of the community members who told us that they use Spring Data, nearly 80% end up using Spring Data JPA, and for good reason. By Torben Jansen, let's discuss building fast and scalable persistent layers with Spring Data JPA.
Yeah, thank you and welcome to my talk on building scalable persistence layers with Spring Data JPA. So my name is Torben Jansen and I'm an independent consultant specializing in JPA, Hibernate, and of course, Spring Data JPA, so typical Java persistence stack for most applications. If any one of you wants to learn more about all of these topics, I invite you to visit me at torbenjansen.com, where I publish new articles on these topics every week. But now let's dive into today's topic, and that is how to build fast and scalable persistence layers with Spring Data JPA. And what do we actually need to do that? Well, we need to be able to find problems as early as possible. And when I say as early as possible, I don't mean we recognize them when we get a support ticket or when our phone rings and the customer tells us that nothing works anymore. Finding them early means finding them during development or during the test, but not after that. And after we found them, well, we need a way to avoid and fix them, of course. And today, I want to show you a few options that you have to do exactly that. So when we're working with Spring Data JPA, we need to keep in mind that there's an underlying persistence layer. In most Spring Boot projects, that is Hibernate. And because Spring Data JPA sits on top of Hibernate, we can, of course, use all the features provided by Hibernate, but we also need to follow all the best practices and need to avoid the specific pitfalls of that persistence provider. You can, of course, also use Spring Data JPA with other persistence providers like Eclipse Link, for example. And almost everything of what I show you today is also usable if you're not using Hibernate as your persistence provider, with one exception. And that is the following part, the part when I talk about identifying issues. Because we need to look into our persistence provider to understand what's actually going on there, why performance issues arise, and what we can do against them. And Hibernate has a really useful feature for that, and that is the statistics component. Because internally, Hibernate, of course, knows when which statements got executed and how many of them got executed and how long that took. And we just need to tell Hibernate that we want to know these information so that Hibernate, and with that also Spring Data JPA, is no longer a black box, which is one of the most common complaints when people have any complaints about Spring Data JPA. And to get these informations, we need to set the property hibernate.generateStatistics to true. We can do that in the application properties file, and I will show you in a few seconds how you can do that. But what I would actually recommend for real-world projects is to set that as a system property on your development machines, because then you are rather unlikely to ship that setting to production, because collecting all this information takes some time and slows down your application. And in my experience, if you activate that without having any performance issues in production, you will most likely have some afterwards. So better don't activate it in production. Use it for test and development. And well, when we activate the statistics component, we of course want to get as many information out of it as possible. And because of that, we should also set the log level of org hibernate stat to debug to get some more information. And I will show you in a few seconds which information we get there. But before we do that, I want to talk about a second feature, a rather new one. And that is the slow query log. So we can configure a threshold above which we consider a query as slow. And then Hibernate will log out all the statements that were slower than this configured threshold. So let's get into the IDE and give that a try. So here you can see my application properties file. And I set the hibernate.generate statistics property to true. I also set the log level to debug. And I configure the slow query log down here to log all queries slower than 3 milliseconds. So if we do that and then run this simple test case, here I have a player repo, which is my chess player repository, which will be one of the main interfaces we will be using in this demo here. So that is a standard JPA repository, nothing fancy. So let's run this test case. We just call the find all method on that player repo, which is the standard find all method provided by the JPA repository. And if we take a look at the log output, then we can see in a second what we get from the statistics component. And the first thing we get is this block here. At the end of each session, we get a summary of the operations that were performed during that session. So we can see here we performed 20 JDBC statements. We had 0 JDBC batches, and then we had some cache interactions. And then we performed a few we performed one partial flush and no complete flush, right? Because we just read a few entities. The interesting part, and the one that you should recognize if you would write this test case in your application, is the part up here. Hibernate tells us that we prepared and executed 20 JDBC statements. If you look at the test case again, we just had a find all method. That doesn't look suspicious at all. But anyways, we executed 20 statements, and now it's our job to figure out why that happened. And if we scroll up a little bit, I'm also logging the SQL statements. You can see here that we have a statement that selects a tournament for a player, and another one, and another one, and another one. Well, you probably already know what's going on here. There are 19 of these. And somewhere up here, yeah, that is the query that we initially executed, the one that selects a chess player from the database, or all chess players from the database, and there are 19. So we have a typical n+1 select issue here. And there we also have the output from this slow query log. This query took 4 milliseconds, and Hibernate also tells us which query that was. So now we know, okay, we're executing too many queries, and we have at least one that's a little slow. So we can now use this information to improve the performance of our application. And that will be the stuff that we will do for the rest of this session. So what are typical reasons for performance issues with Hibernate? Well, we just saw one. We saw one of the most common ones, the fetching of associations. And there we configure the fetching behavior using the fetch type. That's part of the JPA specification and part of our entity mappings. The fetch type defines when a relationship will be fetched. So will we fetch the tournaments when we instantiate a new chess player, or do we fetch the tournaments when we access the association from the chess player to the chess tournaments? The first one, where we initialize it immediately, is called fetch type eager. And there we fetch the association whether or not we use it afterwards. And that is the default for 2-1 associations. And lazy is the more efficient one. That is also the default for the many associations. And there we fetch the association when we actually use it in our code. So that would be the preferred approach. But I don't want to talk too long about that, because I expect that you already know about eager and lazy fetching. The more interesting question now is, what do we do about that? Well, what we can do is we can use query-specific fetching to improve the fetching behavior of our application. So let's say we stick to these recommendations and we use we use lazy fetching for all too many associations and for most of our 2-1 associations. Right? In best case, we would use it for all 2-1 associations, but let's be realistic. Most persistence layers or domain models don't have any fetch type configured for the 2-1 associations, and switching everything from the default eager fetching to lazy fetching is usually a lot of work and not always provides huge performance benefits. So let's say we have fetch type lazy in our domain model. And we will change that in a few seconds in the demo. So then we need to address another issue, and that is the typical n+1 select issue caused by lazy fetching. And that means that if you have a code snippet like the one here at the bottom of the slide, then each access to the books association, each access to the books association triggers another query. And if we select n authors in the first query and then iterate through them, we execute these n+1 queries, and queries to initialize the books association, one to get the authors. And that is something that causes severe performance issues. If you Google about that, then you will find some suggestions like use fetch type eager and hibernate specific fetch mode and all these kind of things, but please don't do that. We just saw in the previous test case why fetch type eager is a bad idea. There we initialized the association even though we didn't need it. There are two better options for that, and that are the fetch join clauses that I will show you in a few seconds, and entity graphs, which enable you to override the lazy fetching modeled in your entity mapping. So the first thing I need to do is I need to fix that part here. Typical many-to-many association between my chess player and my chess tournament. And you should, of course, never set fetch type eager in a real application. So when I do that and just run this test case, let's take a quick look at the method here. The find with tournaments by method just is a derived query, just selects all chess players from the database. And if we execute this test case where we get all chess players and then iterate through them and print out the name and the number of tournaments, then we can see in our log output that we again have 20 queries, and we have one select statement that gets the tournament for each player directly before we print out the corresponding log message. So probably familiar what's going on here. This call of the getTournaments.size method triggers another query to get the tournaments association here. And that is what we actually want to avoid, because, well, first of all, it only works in the transactional context. And, well, you saw the second reason, it's causing a lot of queries. So let's use the fetch join clause or join fetch clause that I just mentioned on the previous slide. So you can use it with a query annotation so that we can define our own query statement for this specific repository method. And what do I do? Well, I select chess players, and then I do a left join fetch on t.tournaments. If we take a look at the chess player entity, we can see that tournaments is our mapped many-to-many association. So by doing a left join fetch, I tell Hibernate or any other JPA implementation to initialize the tournaments association on each and every chess player that we get from the database. And you will see a huge difference in the log output. And in most applications, also a huge performance improvement. So let's see here. Now we have just one JDBC statement. And you can see here that we printed out a lot of log messages with famous chess players and the number of tournaments they have in our small test database. So how does that work? You can see the query here. So we have our chess player, and then we have two left outer joins from the chess player to the association table, because it's a many-to-many association, and then to the chess tournament table. And well, that's expected, right? That would happen with an usual join clause as well. The special part about the join fetch clause is that it also extends the association table, the projection. It selects the records from the association table and all columns from the associated chess tournament. You can see that here with the chess turn 2 alias, where we select the end date, the name, the start date, the version, and somewhere up here also the ID. And well, your JPA implementation uses that to instantiate here a list of tournaments and fill it with chess tournament entities, fully initialized managed entity objects, just in the same way as if you would have just called the getter on a lazy association, and Hibernate would have fetched it with a separate query. Yeah, if you have any questions, feel free to post them in the Slack channel. I see there are already a few people. Post them there. I will take a look at that maybe during the talk as far as possible, or afterwards in the Q&A part. So let's get back to the chess player repository. We already improved the use case using the test case using the left join fetch clause from the chess player to the tournament. And there's a second option, and that is an entity graph. So normally, using plain JPA, we would need to define a named entity graph like this. So annotation-based, give that thing a name and define attribute nodes. And these attribute nodes specify which entity attributes on the entity that we select we want to initialize. And in this case, it's of course tournaments. So what I could do now is I could reference this named entity graph by name in my repository and set it as the value attribute. But there's actually an easier way, and that is using the attribute path attribute, where we can just put in the name of the attribute we want to initialize, in this case, tournaments. So let's get back to the test case and run the test case again. Take a look at the log output. There we can see that we again just used one JDBC statement. We have here all of the log output, and here we have the same query statement as we had before. So we join from the chess player to the association table and from there to the tournament. And here we select all information from the chess player and all information from the tournament. So by doing that, again, we have all the information that we need. One thing that you might have recognized is now we have a slow query statement here, because our query is, of course, getting more complex than it was without fetching the chess tournament. And that's the case for join fetch clauses and for entity graphs. As you see in the SQL statement, they create the same statement that's sent to the database. So one thing you always need to keep in mind here is your query gets more complex. You're selecting more data. You're selecting not only more columns from the database, you're also creating a product with each join. So now we get each chess player as often as she or he has played in a tournament. And because of that, our result set grows rather quickly. And that is always something you need to keep in mind, because you can, of course, now use multiple join fetch clauses in this query. Or you could create more complex entity graphs. And as long as you model your too many associations as Java util set, Hibernate generates you all kinds of queries. Even one with 7, 8, or 10 join fetches. And I've seen that in multiple projects. And that will not solve your performance issue. It will replace your n+1 select issue with a new problem, because now the query will be really slow because you're selecting thousands of database records, millions of data points. And if your DBA looks at that query, they will probably just shrug and say, well, that query is that big and complex, I can't do anything about it. And that's because we are selecting the wrong stuff. So please be careful about using complex entity graphs. Please be careful about using multiple left join fetch clauses. There are some people who say you shouldn't join more than one association. I don't see it that strictly because there's a difference between joining an association that contains 1, 2, or 3 records compared to one that contains a few thousand. But the general idea is correct. You should always take care that you don't join too complex associations and not too many of them. Okay, that's about association fetching, at least for now. The next thing I want to show you is a small pitfall that is Hibernate specific. And that is the handling of many-to-many associations. So you probably know you can model a to-many association as a list, a set, a map. You have quite a few options there. And from a Java point of view, you would probably prefer a list as a simple data structure for a to-many association, because at some point, all of us learned lists are a little more efficient than sets because we don't check for duplicates and all these kind of things. Well, you can forget about all of that if you're using Hibernate as your persistence provider with Spring Data JPA, because Hibernate handles these lists rather inefficiently for many-to-many associations when you perform write operations on them. And that is something we will take a look at now. So here we have a chess tournament, and I get just one chess tournament from the database. And I decide, okay, player with ID 34 shouldn't be part of that tournament. Maybe they signed up in the beginning and then for some reason they can't attend. So I decide to remove that player from the list of players that participate in that tournament. What we would normally now expect is that Hibernate executes a query that removes the one record from the association table that matches the chess player with the chess tournament. But if you look here, then you can see that Hibernate is obviously doing more than that. There are 18 JDBC statements, and 18 is a lot. So what's going on here? We already see it here. We have an insert statement on the chess tournament players table, but we are not adding anything to the association. We have another one, and another one, and another one. So you might already have an idea what's going on here. Well, if we scroll up, you can see that we have a bunch of insert statements here. And here's the delete statement. And that was what we expected. We were expected to see a delete statement, but not this one. Because here we're removing all the records from the chess tournament players table with the tournament's ID that is equal a provided value. So right now we are removing all players from the tournament, even though we just wanted to remove one of them. And then Hibernate re-inserts each and every one of them who's still in the list. And as you can see here, that is rather inefficient on an already small list of players. It gets worse if you do that on associations with more elements. That would be a tournament with 256 players, for example. We would re-insert 255 records. And there's an easy way to solve that. And that is, where's my tournament? Here's my chess tournament entity. There's an easy way to solve that. And that is, we switch the data type from list to set. When I do that up here, I, of course, also need to switch the data type down here. Oops. No. Like this. Okay, so now we work with a set instead of a list. Let's see how that changes the whole database interactions. Okay, so it's much better than before. Instead of 18 statements, we are now executing 4. We have the delete statement that we expected. So we now remove that one specific record from the association table and nothing else. And that's more than good enough. And then we, of course, have a select statement to get the chess tournament and the chess player, caused by these two get by ID calls. And then Hibernate needs to internally update the chess tournament table as well when we're removing the record. But that's a Hibernate specific thing that unfortunately we can't change. But what we can avoid is these additional 14 statements that re-added 14 players to the tournament, even though we just wanted to remove one of them. Okay. So that's all about association management for now. We had a look at the fetch types and said, okay, we want to use lazy fetching for all of our associations. But when we do that, we also need to make sure that we fetch all the records that we need for our current use case as efficiently as possible and avoid the n+1 select issues that we just saw. So there we wanted to use try fetch clauses or entity graphs to tell Hibernate or any other JPA implementation that's used by Spring Data JPA to fetch the required records from the database. And then we also need to make sure that we use the right data type to avoid any inefficiencies. And with the standard Spring Boot project, when you add Spring Data JPA, you usually get Hibernate as your persistence provider, and that handles these lists for many-to-many associations rather inefficiently. So please use a set and ignore the theoretically slower performance of Java util sets compared to Java util lists, because you will not recognize them until you add several thousands or probably a few million elements into the set. And well, if you fetch a few million entities from the database, the performance of your list or set will not be the thing that makes your application totally unusable. It will be the database query, the network traffic, and all the other things. Okay, so I mentioned earlier that if we join fetch a lot of associations, then we are usually selecting the wrong data. We are selecting way too much. And that is, of course, always one angle from which we can tackle performance issues. We should only perform the operations that we need. And that includes, we should only select the data that we actually need for our project or for our use case, and we should select it in the way that's the most efficient for that use case. And we can choose between 3 different projections with Spring Data JPA. We can select entities, which are great for write operations because they are managed by the current persistence context. And that means when we call a setter method on an entity object, then the change will be committed to, or will be updated in the database before the transaction gets committed. We can be sure that we just have one entity instance for each database record within one transaction and all these kinds of things. So all the benefits that we have for write operations are based on entities, their lifecycle model, and the functionality provided by the persistence context. And that makes, well, entities the best option for write operations, of course. But what about read operations? Well, if we just read the data, then we don't need a lifecycle management. We don't need someone check if we changed any attribute value to then generate SQL update statements, because we know we just read them to, I don't know, present them in the front end or do some calculations, but not to change anything. And in all these cases, we should try to keep the overhead of this management functionality as low as possible. And there are 2 options for that. That are scalar values and DTOs. And both of them are, well, based on tests that I ran on my local machine, at about 20% faster than entities if you select exactly the same data and run database and everything on a local system. So just the management overhead slows down the instantiation and management of the object that's performed by your persistence provider. So the question then is, well, if scalar values and DTOs are better and faster for read-only operations, which ones should you actually use? Well, I would say you should not use scalar values at all, because a scalar value projection is an object array. And then you need to iterate through that array and remember, okay, I selected the first name in the first column and the last name in the second, and then the date of birth. And then you need to access these elements by their index and extract them from there. And let's be honest, nobody wants to do that. It's annoying, it's hard to maintain. And compared to DTOs, it provides almost no performance benefit. And that's why DTO projections are my recommended projection for all read operations. And if you're just using plain JPA, then you would only be able to use DTO classes. So there, and we will do that in a few seconds, there you need to implement a class with a constructor and getter and setter methods and everything. And well, your persistence provider could instantiate objects of that class for your query result. Spring Data JPA makes that a little easier. You just need to define an interface. And Spring Data JPA will then generate a class based on that interface definition. So let's give that a try. So here we have a simple query that's a derived query and selects a player name object based on a first name. So what is player name? Player name is my DTO class. So that is what you could also do with plain JPA or Hibernate. There you would write JPQA query with a constructor expression. Luckily, we don't need to do any of that. So here you can see just a basic Java class, no entity annotation, so it's not managed. That's why it's faster. So first name, last name attribute, a constructor that sets all attributes, and if you get and setter methods. So if we now go to, let me close a few things here. So if we then go to the test case and run this test, then we will see an important difference compared to all the queries that we had before. In all the previous test cases, we worked with entity objects, and that meant that our persistence provider had to select all columns mapped by that entity class and then instantiate a managed object and set all attributes. In this case, we only wanted to get the first and last name of the chess player, in this case of the current world champion. So a query statement that just selects first and last name from the database would be more than good enough. And we get exactly that if we are using DTO projections. You can see the generated query here. So that is the same thing you would write in plain JPA or Hibernate with a constructor expression that describes a constructor called the player name class with first name and last name. And then we see here, okay, we got a player name object. And there's, of course, the information in there. But there's an easier way to do that with Spring Data JPA, as I promised you earlier. You can use an interface and just define the interface with a few getter methods. And as long as the getter methods match the name of getter methods on the, in this case, chess player entity, Spring Data JPA will generate a query for this method definition, a derived query, and instantiate the player name inf objects for you. So I already executed the test before we switched to the repository. And you can see that here, a player name inf is now one of Spring Data JPA's lovely named internal classes. You can see that there's the first and last name of our chess player. And if we scroll up here, we can see that we executed exactly the same SQL statement as before. So we select just the first name and last name from the chess player table. And the only difference here is that is now handled by Spring Data JPA the instantiation of these objects and not by the constructor expression. But that is a detail that doesn't have any impact on the performance, at least not in this case. So that makes things a lot easier. When I'm talking about these DTO projection, I also get always asked about how to use them with native queries, because native queries are great as soon as your query gets complex, as soon as you have to extract data in a complex way for some reporting use cases, or where you need to transform data and stuff like that. So all the things that you usually can't do with a derived query and also not with a JPQA query. And well, I tried that here. So in theory, the alias from the query could get mapped on the attribute name of the either DTO class or the interface. So let's try to do that with the DTO version of it. So where we get player name object. And you can already see it here. My test case expect that a converter not found exception gets thrown by Spring. And where is it? Here it is. Here you can see that we now got a converter not found exception, no converter found capable of converting. That is the same lovely class name that we had before, to player name. So now there are various ways to fix that. One would be to define an SQL result set mapping, which is an annotation-based mapping definition defined by the JPA specification to map a native query result to any kind of data structures, entities, DTOs, scalar values, whatever you need. And then define a named native query. And when you define the named native query, then also reference the SQL result set mapping there as well. But that's more complicated than it has to be. What you should do instead is, if you want to work with native queries and want to use a DTO projection, then please use an interface like this one, right? The one that we used before. Because if you do that, then Spring Data JPA handles all of that for you. So here you can see I call my native by first name repository method, which is this one up here. Same SQL statement as we executed before. The only difference between these two methods is the return type, the interface in this case. And this time, well, we got the name of the chess player here. You can see that everything worked as expected. We have our native SQL statement here, which is exactly the same as I defined as the query. And Spring Data JPA was easily able to map that to the generated object that implements the interface. But that's not all of the things that you can do with Spring Data JPA and DTO projections. The Spring Data JPA team took it one step further. You can also use nested associations and Spring expression language on your interface-based DTO projections. But please don't do that for performance critical use cases. It looks great as a feature. It technically works fine. Unfortunately, you lose the benefits of using a DTO projection. So let's take a look at an example. So here I have my tournament interface. And well, that's a rather handy DTO projection where I have the name of the tournament and a list of player name interfaces for all players who participate in that tournament. So that's great to present the tournament with all the players on a website, for example. And what Spring Data JPA will do is it will use the get name getter on my tournament entity to get the name of the tournament, call the get players getter on the tournament to get the get all players of the tournament. And for these chess players, Spring Data JPA will use the player name interface, or rather the object that implements that interface, the class that implements that interface, as a projection. So let's run this test case and see what happens. So we would print out the number of players who participated in the tournament and the name of the tournament in a log message. So first of all, we see here that we executed 2 JDBC statements, which is probably more than we expected, considering that we had one query that was supposed to get all the information, right? So the next surprise is up here. We not only selected the name of the chess tournament, we selected the entire table. We selected all columns mapped by the chess tournament entity class. And then we see this output here, which is that log statement. So before we print out any information, or any information from the tournament, we see here that we got another statement that selects the players of that tournament. And then we have the log statement. So based on this chess tournament, tournament inf projection, we selected all chess tournament entities and we selected all chess player entities that are associated to that tournament. And we lost all the benefits of the DTO projection. We now have a bunch of managed entities in our current persistence context. We selected way too much information. And all of that just because we have this get players thing here in the in our tournament interface. Something similar happens if we do use the expression language. So here you can see my player full name interface, and there I use the expression language to concatenate the last name, comma, and the first name. So I just want one getter method that I call to get the full name of the player, because that's just a little more handy than concatenating that myself. So if I now run the test case, there it is. Then you can see here that that the test case passed. That's at least something. We printed out the name of the player and we just used one statement, so not too bad. But what did we actually select? Well, we again selected the entire chess player entity. Even though we just defined our player full name interface, which just referenced the last name and first name attributes in this expression language. Well, the reason for that is we use the expression language. The only thing Spring Data JPA can do is get the entity and then apply the expression language on top of that. Unfortunately, that gets us to the point where using a DTO projection doesn't make any sense. I mean, we now defined an additional interface to perform the same work as if we would select an entity class, but actually get less because we don't have access to any of the other attributes of the entity and can't use it to perform write operations. There's a better way to do that. I defined my better player full name interface, and that doesn't use expression language, as you can see. That one uses 2 getter methods that match the getter methods on the chess player entity, and I have a default method, get full name. And that one does in the Java code the same stuff that I did previously in my expression language. And if I now run that test case, then you can see that the result is the same, and we only selected the 2 columns that we actually need. So now we again have the full benefit of our DTO projection. We didn't select any entities. That means we didn't select all the columns mapped by the entity, and we didn't instantiate managed objects, which actually means with Hibernate, we are instantiating 2 objects for each entity so that it can perform dirty checks. Because we didn't do that, we have no flush interactions down here because, well, there are no entities that Hibernate could flush. And all of that gives us way better performance than using the expression language as in the example before. Okay. That's all about projections for now. So when you're working with Spring Data JPA, please keep in mind there's a database in the backend where queries get executed, and you should only select the information that you need, and you should select them in a way that's ideal for your specific use case. And that means for write operations, you should use entity classes because they support the entity lifecycle model, they support the automatic generation of SQA statements and all these useful things. And for read operations, please use DTO projections. There you don't have the management overhead of entities, and you can fine-tune your projection to the data that you actually need. And that means you select less data from the database and you store less data in local memory. When you do that, please be aware that DTO interfaces are the easier approach with Spring Data JPA, but that you shouldn't use these advanced DTO projections like nested associations and Spring expression language. Okay, let's talk about the last part of this talk, caching, which is the go-to method for a lot of development teams when they are thinking about performance problems. Because we have a lot of data that we read over and over and over again in our application. And, well, wouldn't it be just better if we select it less often, if we store it in local memory? The answer to that is it depends, as so often. So let's take a look at this. What I'm showing you now is caching as it's defined by the JPA specification and implemented by Hibernate. On top of that, you have application caching. So there you can use other approaches to cache stuff within your application, but not the persistence layer. But that's a different topic. So if we are talking about caching in JPA, then it gets a little tricky. So most developers think, okay, we have somewhere a Hibernate session, and that somehow interacts with the database. That's not entirely wrong, but it's only a small part of what's actually going on. So within each session, we have a first level cache. That one contains all the entity objects that we persisted within the current transaction or read from the database. So that ensures that you don't trigger a database statement every time you call a setter method on an entity object. And that ensures that you only have one object representation of each record in the database within each session. But as you can see, it's pretty hard to get any real performance benefits in a multi-user system out of that, because each user has its own session and we don't get any benefits if someone else read that data. We get that with the second level cache. That one contains entity objects. And then we have a Hibernate specific cache, the query cache, which technically is part of the second level cache, but it's so different that it's easier to present it as a second session independent cache. That one contains query results. We will not have enough time to get into the details of the query cache, but let's focus on the second level cache. It's the one that's used more often anyways. So the second level cache contains just entity objects and gets used whenever you find an entity by its primary key. So when internally the entity manager find method is called, or if you traverse association. So if you call the getter method on a managed association. Well, under the condition that the information is available to that, but more about that in a few seconds. So you saw that in the last diagram. This cache is session independent, and that's why it's so useful in multi-user applications, because there you can benefit from the situation that someone else read the same data just a few seconds ago. But that also creates some additional problems, because now you have an external cache that you need to keep in sync and that you need to check before you execute a query. And all of that takes a little bit of time, creates a small overhead. And that means you need to have enough hits on the cache to compensate for all the overhead. And a rule of thumb when using Hibernate is about 9 to 10 successful read operations for each write operation. You need to activate the cache in your application properties. I will show you that in a second. And you do that by choosing the shared cache mode. You have the choice between all non-enable selective, disable selective, and unspecified. I recommend using enable selective. Using disable selective is also fine. Enable selective means you need to annotate your entity class if you want to cache it. In that case, you hopefully think before you add an entity to the cache, and you are sure that you have the 9 to 10 read operations per write operation. Disable selective is the opposite. That's cached by default, and you need to deactivate it, which also works, but to me always feels a little risky. Okay, what do we need to do now? I have a player controller. That's just a simple REST controller. And that's where did we left off? We had a quick look at the chess player controller, where we just get an entity by its primary key. And we have this test case where we call the player controller twice. So what do we need to do to activate the cache so that now these two calls of the get player ID don't trigger two database statements? Well, first of all, I activate the shared cache mode and set it to enable selective. And now we need to take a look at our entity classes. We have the chess player. There I have a cacheable annotation at the top, which is part of the JPA specification and just tells my persistence provider to cache this entity. And I do the same for my chess tournament. And now comes an important tip. You should also do that for your many-to-many associations and for all associations on entities that don't map the foreign key column. Because in that cases, Hibernate doesn't cache the association between these two objects. Let me quickly start the test case and then I keep explaining. So this is important because otherwise you would cache the chess player and the chess tournament in your cache, but you wouldn't cache the association between the two. And that would mean that when you call the getter for the tournaments attribute, Hibernate would trigger a new database query because it doesn't know which tournaments belong to that player. And that's something that always causes confusion. So what do we see here? We have our first iteration there. We select the chess player from the database. We put it in the cache. And the second one doesn't need a JDBC statement. We just got the object from the cache. And unfortunately, now I see my time is almost up. So don't worry, we covered all the important parts. And I hope to see you in the Q&A call in a few seconds. And if you want to follow me and all the Spring Data content that I put out, then please visit torbenjansen.com. Hope to see you in a few seconds in the Q&A call.
Thank you, Torben. That was awesome. As with every session, Torben's headed over to the post-session Zoom now as we speak for your questions and your comments. You'll find a link to that Zoom in the Slack channel for this talk, and the Slack Q&A will continue for some more time today. So make sure you make the most of it.